Greetings, Commanders. Today we're doing something a little bit different. We're going to be taking you on a guided tour of our very own solar system with some help from our friends at the Science Museum. Earlier this year, I was joined by two wonderful curators at the Science Museum, Abbie Mackinnon and Laura Joy Pieters, for one of their lates. We were joined by 60 or so guests, and now you're one of them, and we took them on a guided tour of the solar system. Starting at Earth and then moving on to Mars via the Moon, we chatted everything about space and what could or might be in our future. Now, whilst our game is set 1,000 years in the future, the basics of it are grounded firmly in reality. If you want to follow on, you absolutely can. There'll be timestamps down below. So have a look and enjoy.
Good evening, everyone, and welcome to the Science Museum Lates. I'm Arthur from Frontier, and today we have a very special tour of the solar system in Elite Dangerous, starting at one of our stations, which is the Abraham Lincoln Station. So our wonderful pilot, he's over there, there's Max. You're going to take off and just put us, I think we're over Earth, right? So we're going to start at Earth. Where would you like us to start this tour? Is there anything you want to ask me about the game, or anything you want to start, like any places you want to go in the solar system?
Well, we were talking about this, and we were wondering how we start from Earth's orbit. Like, how do we get there? Is there a sort of sky elevator, or do we just fly there?
I think we're about to find out.
Okay, so there's some elite fans in here. So, but basically, we try and base the game around as much Newtonian physics as possible. So you can launch from a space station, you can launch from a planetary surface. So different planets have different levels of gravity, which is all simulated in the game via an engine which we call the Stellar Forge. So when Elite Dangerous was created some 10 plus years ago, it used all the relevant star charts and data that was available at the time. So the night sky you see there is actually the night sky. It's not a simulate. It's not a skybox, which in games terms means a fake sky. Those stars there you can actually travel to. So it's a one-to-one simulation of the Milky Way galaxy. I think circa 400 billion stars, each with their own systems. And the flight model is based around physics. And Max is flying FA off, which is flight assist off, because he's better than me, which basically means if you spin the ship and release the controls, it will continue to spin. So there you go. So that's why I don't fly like that, because I get very sick very quickly. So that's basically what Elite Dangerous is and how you might take off from a planet or a space station.
And so, interestingly, sometimes spacecraft also spin like that when they're traveling, because it means they don't have to have any power, they can conserve energy, and they just sort of flip until it's time to turn the thrusters on and then straighten out. So it's a useful technique sometimes too.
Very useful. I mean, our players will use it for various techniques. Sometimes it's combat, where they will be traveling one way and then just flip to, as they still carry on traveling one way, they're facing the other way. I tend to have the assistance on because I am not a good pilot. So we're at Earth. There we go. That's the beautiful blue marble that is Earth. Is there anywhere in particular you want to start our tour?
Can we go to the Moon, please? Mars via the Moon.
Mars via the Moon. Okay, so we're going to go into what we call super cruise, which is a super fast speed. So Max is going to line up to the Moon and we're going to head there. So in reality, it would take a lot longer than this, but we have a very fast sci-fi engine. So as we said there, one thing to note here when you're looking at what you're seeing on screen there, that night sky is an actual render of the night sky. It's not a fake, it's not a skybox. Every single star you see there is exactly where it should be in the night sky, and every single one of those stars you can visit. It may take you a long time to get there, but you can visit it. So it's not what we call in the industry a skybox, which is like a fake sky. So it looks very pretty but doesn't do anything. This is legitimately, you can navigate by the stars, and it is based on the data that we had 10 years ago. What's so important about the Moon?
Where we're heading next in terms of exploration is the Moon. I mean, already there have been lots of missions recently, both from international space agencies as well as private space agencies, landers on the Moon, rovers. NASA's Artemis mission is looking to put humans back on the Moon for the first time since the Apollo missions.
What's really interesting for sci-fi fans like me about the Moon is when you see the promotional materials for the Artemis mission from NASA, there's like swelling orchestral scores, there's like hero shots of everyone working on it, and it is a very inspiring mission, but NASA knows that it needs buy-in for something like this, and we talk a lot, there are some colleagues of mine in the room here, we talk a lot about astronomy as a science that engages a lot in blue sky thinking and blue sky research. There isn't like a direct benefit, it's not going to like potentially cure a disease or anything, that's all sort of secondary, but it needs a lot of buy-in to raise the sort of millions of pounds needed. The other interesting thing from a sci-fi perspective is that during the first Apollo missions, we didn't really have imagery that we're super familiar with from the moon and from space. And now we are saturated with imagery from CGI, Hollywood blockbusters. We kind of know what it's like. And we were sort of having a conversation earlier about what would be really intriguing about new space imagery. Like, what is it? And actually, our host was talking about the sounds from different planets.
Yep.
And so that's sort of like, what would really surprise us about space at this stage when we feel like we know so much, but we're also inundated with sort of realistic impressions of what it looks like, when back in Apollo, it all felt very new and it all felt very fresh.
Yeah, absolutely. And I think also with the moon, it's very much going to be used as a sort of jumping off point eventually for exploration of other planets, especially Mars. And it really is kind of a stopgap. There's still lots to learn about the moon and lots of science to be done. But a big push for going back to the moon is so that we can then go to Mars. It's a lot easier to launch spacecraft from the moon than it is to launch from Earth. And so, an eventual moon base is definitely in the works and a high possibility. Probably going to take a lot longer than what's currently scheduled out, is my guess. Most of these things do. But yeah, the moon has been and will continue to be in the news quite a lot.
We also have a piece of the moon downstairs in the Science Museum from the Great Scott Moon Rock. You probably know more than me.
Yeah, the Great Scott Moon Rock, Apollo 15, collected by David Scott. The most sort of, if you imagined what an Apollo astronaut looked like, you would imagine David Scott. He's sort of ridiculously handsome.
He looks exactly like me, actually. So, but also we have. I asked this question earlier on because I am learning as always, and I'm not sure what I've heard is true or what is myth. But the dark side of the moon is a real thing, right? So can you explain, as you did to me, what the dark side of the moon is?
Yeah. So the moon is tidally locked with Earth, which means we only, when we look up, only ever see one side of it. So there is, a dark side to us of the moon, and I believe that China is the first country to successfully land a spacecraft on the dark side of the moon, and they also returned some lunar dust samples as well. So maybe one day you'll see some lunar dust from a China mission on display in the Science Museum.
In the Science Museum.
If there's anyone who has connections, talk to me after.
Hook us up.
A final point I'd love to shoehorn in about the moon, which is more ideas-based than Abbie's amazing tech stuff, is basically throughout entire human history, as far as we know, we've all looked up at the moon and there's been no lights, no signs of settlements. We know that, there's a few footprints and flags up there. But in this game, 1,000 years in the future, the population of Earth or whatever will look up and see lights on the moon because it's permanently inhabited, right?
That's correct, yeah.
And that's something that could be potentially in our future, where that vision of the night sky that we all share, that we've all had throughout human history, might change. And what will that mean for our relationship to the cosmos?
It's a really interesting thought, and one I hadn't even considered until we spoke earlier on. Okay, so we've had a look at the moon, and I know this, it's the closest body to Earth, right? I've got that one right. But we're going to go on to Mars.
Yes, please.
We're going to go on to Mars, probably one of the most famous of all the planets. So, Max, if you would, could you engage the Super Cruise and head us towards Mars. Now, as we're heading towards Mars, what you might notice is something that the elite players will know is called the loop of shame. So if you're going too fast, you will pass the celestial body and have to loop back. It's a rite of passage. If he does do it tonight, elite players, you can jeer him, everybody else, just go, oh, sad. You'll know he's done it because he'll be weeping in the corner. So as we head towards Mars, what can you tell us about Mars? And because it's slightly different in our game, because it's 1,000 years in the future, and something we weren't able to share with you earlier on. Whilst it still has a red tinge, in our game it now has an atmosphere. Because we have terraformed Mars. Now, as we head towards Mars, before I have a look at it, do we think that's something that's possible in the future? I know we discussed this and we talked about like what's the likelihood might be. Tell me what you crush my dreams again.
I'm going to let Laura Joy do this one because she spoke very well about it earlier.
I spoke to a brilliant scientist at Imperial, and I will not name him in case that he doesn't want this information public, but he is a Mars expert. And I asked him, I was presenting him with this child's idea of, if everything goes wrong on this planet, can we just move the whole population over to Mars? And he said, no way. There's no way that Mars will wholesale sustain a human population ever. What might happen is that we can establish a settlement there. Max, maybe a few hundred people will live there. But essentially the only way we can live on Mars if we have this sort of like metaphorical umbilical cord back to Earth. You know, we've spent billions of years evolving to live here, and we'll need to be able to send the resources needed to live on Mars. So the people that live there won't be just people hanging out. It will be scientists. They'll be there to do science. They'll be there to figure stuff out. It won't be a thing. And also we were speaking about the sort of psychological impacts of living on a different planet. Obviously, in this version of the game, you've terraformed it beautifully, I imagine, and the sky will be blue.
Yeah.
But really, it's,
There we go, you're seeing it coming.
it's not like that.
You've played this before, haven't you?
There's a lot of very fine dust on Mars, and if anyone doesn't like getting sandy when they go to the beach, imagine that feeling of sand in your bed and everywhere you go, but like consistently with a very fine dust that you'll breathe in, get into your lungs. That's just one of the problems. But essentially, we'll only be able to support life on Mars because Earth will be sort of supporting it, is the view of one expert.
And a note on the sort of psychological side of, you know, going and living in a place like Mars. NASA and other space agencies are doing active research on this kind of element of the psychology of being isolated, being in small spaces, being, you know, only around a few people for long, long periods of time. It takes up to 9 months to get to Mars. On a, you know, what would have to be quite a small spacecraft. And so there's analog stations in areas around the world. There's one in Antarctica, I think there's one in Canada, there's one in
A desert somewhere?
the desert somewhere in North America, where they do these long missions of, you know, up to a year, where they're living with a group of people and they're having to perform activities in science and learn to live together. So there is quite a lot of work going into that, and it's not to be underestimated.
It's 55 million kilometers away at its either average or closest point, but essentially if we were to go there, spend a little bit of time there and come back, you'd need enough food for 3 years. So that's a lot of tinned food that you'll be
I would need
Yeah.
more. I would need more. But this is why I guess Elite is different, right? With 1,000 years, and I guess if you would need as much food as a sandwich and a cup of tea to go there and back, and your tea would still be warm because we're 1,000 years in the future. But it's a very interesting point you raise about the psychology of living on a different planet and how that will affect us quite significantly for being so far away from home. Is there anything else you'd like to talk about Mars, or should we move on somewhere else? You're more than welcome to hang around. Is there anything else you want to talk about? We can go on somewhere else.
I'll maybe just mention that it is the only planet entirely inhabited by robots.
Oh yes, that's a good one. Tell me more about, because there was 2 robots that are currently active.
Yeah,
right?
so there's been quite a few robots on Mars, but there's 2 active ones, Perseverance and Curiosity. And then Perseverance had the Ingenuity helicopter, which some of you might have heard of. It kind of made the news a few times, making some pretty epic flights around, and that's kind of a unique way to be able to travel around Mars, to be able to kind of overcome the really thin atmosphere, and to be able to fly a craft like that. It can go much further distances than the rovers, which actually travel very slowly.
Yeah, they're my spirit animal.
Yeah.
All right, so there we go. That's a sort of brief look at Mars. As we pick our next destination, I think you have the same destination that I want to go to for the same reason, right?
Jupiter.
So a little fact from me is I am taking my first steps into looking at the stars myself. I had a telescope when the planets aligned, and the first planet I've actually looked at through a telescope was Jupiter. We have a shared experience in that respect. I will just say from a personal experience, and I encourage everybody to do this, seeing images of planets is fantastic. Seeing them with your own eyes, it is deeply moving on another level. And I'm now hooked in this game, and I want to invest. But what was it like for yourself?
Yeah, it was the same. And actually, I'm very ashamed to say, I almost don't even want to say it, but it was only this Christmas that I first saw a planet that wasn't the moon, through a telescope. And it was Jupiter. And it was, as you say, incredible to be looking at it, and it looks, and it sounds silly, it looks just like the images on the screen, but it's the real thing, and there is something really special about that. And I could even see some tiny lights around it, which I knew were Jupiter's moons, which are some other special places as well.
Well, we are arriving at Jupiter, and you've mentioned the moons. Do you want to talk to us about some of the moons that Jupiter? Some of the moons.
Some of the moons, yeah, just some. So there's between 80 and 90 moons that orbit Jupiter, which is a lot, and a lot more than most people probably realize. But there's 4 big ones. and I'm going to really attempt to, without my notes, remember all of them and not get them confused with other moons. So there's Ganymede is the biggest moon, and actually Ganymede is bigger than Mercury, and it's bigger than Pluto. So if it were not a moon, it would be classified as a planet. Ganymede's quite special, and there's lots of NASA missions and European Space Agency mission currently en route to Jupiter to study Ganymede and some of the other moons as well. So then there's Callisto, Io, and Europa. And so there's two in particular missions. So the European Space Agency has a mission called JUICE, Jupiter's Icy Moons. Fun fact, most space agencies, when they come up with mission names, they come up with the acronym first, and then they just make it work. JUICE, great name. Jupiter's Icy Moons. So that's looking at Ganymede and Europa. And then there is also Europa Clipper, which is a NASA mission, which is looking at Europa. And both of those planets, Ganymede and Europa, they're icy planets. They've got very icy outer shell, but then they have oceans beneath. So a lot of water. Water is something that scientists are always looking for signs of life. And so those are two very interesting moons.
Well, you've mentioned signs of life, and I'd be remiss to not ask, because I know that you have an interest in SETI. So I'm going to ask the question, because I'm that guy. Do you believe... Oh, actually, should we ask everyone... Hands up if you believe there is life in our galaxy.
In our galaxy?
No, in the Milky Way. You're going to say no. Bigger. In the universe.
Yeah, just out there.
I'm a believer. I think they're here. I'm in the universe. Yeah?
There has to be.
Oh, there's not as many people as I thought, actually, put their hands up. Talk to me. Do you believe that in the universe there is extraterrestrial life?
I think surely.
It's got to be, right?
There's got to be. And I'm very interested in SETI, which is the Search for Extraterrestrial Intelligence, a sort of institute founded in the US. Jill Tarter, an amazing astronomer, was involved in that. And essentially what sort of kick-started this belief that there must be life somewhere out there was the discovery of two things. One, exoplanets, and the other, extremophiles. And exoplanets are sort of planets like ours, orbiting around stars. And extremophiles are organisms, usually very tiny single-celled organisms, that can survive in incredibly horrific places. So deep sea vents is one example. They can live like inside a volcano. We know that life can survive in these really extreme environments. So surely on some of the planets out there must be life. So those two things were very fundamental to this sort of push for SETI. Jill also said that if the universe was all the water in all the oceans, then through SETI, which has been going for several decades now, sort of since the 60s, we have explored or listened to 1 cup of water. So we've got a lot to go to sort of rule out intelligent life or any life at all. But for SETI, it's radio astronomy, and we're listening. We're not really actively putting lots of signals out there. We don't really have the infrastructure for a sort of sustained program. We don't really know yet what we'd do if we heard something or, started a communication. But we're listening, and we're looking for technology, and we're using technology as a proxy for intelligence. We're saying, if there's technology out there, surely it was created by some sort of intelligent group of people, life, whatever they might look like. So sort of like giant techno structures or something that we know isn't going to be a star or some kind of other sort of natural phenomenon. So that's the other thing to remember, technology as a proxy for intelligence.
There we go.
I have a question for Laura Joy, actually. Am I right in that there is sometimes a debate within the SETI community about whether we actually should be putting messages out there, or we should be kind of broadcasting, hey, we're here, because I seem to recall in my very brief foray into SETI that there is kind of a debate about whether or not we should actually be doing that. Is it safe?
We've all seen Independence Day,
ridiculous?
Right? We all know what happens.
So I suppose there is a risk that if we're like, hey, we are a very immature civilization and come check us out, that there might be a sort of apocalyptic scenario. But really, I think that the view of most astronomers is that if an intelligent species has got to the stage of sort of looking around the universe for intelligent life, that they will be curious more than anything. If they do want to make contact, they will just want to know what we're about rather than doing anything violent or whatever. So that's not really a risk, I don't think. I think more we're not putting signals out there because we don't have the infrastructure for that sort of program. Yeah. The other thing to note is that this sort of theory called panspermia, which is the idea that if we find one example of life out there, anywhere, in either the solar system, the galaxy, anywhere, through chemical signatures or this sort of like looking for technology, then we're going to say that there must be multiple different examples of life out there. If we find one, there must be multiple. If we find one, it can't just be us and them. The universe is so big, there must be multiple. So that's a theory as well.
There we go. So we're just orbiting Ganymede now, and I'll just talk to the wider. In our game, there is actually we have found intelligent life in our game. Then there's well, one that is still alive, one that is debate. I've got to watch my words. There's players in the audience, and there's the Thargoids. They're not so nice, but that's probably because we weren't so nice to them. And there's an ancient race called the Guardians who are kind of very smart, maybe ancient computer, maybe AI, which is a bit worrying because we're in an AI-driven world now. But in Elite Dangerous, there is extraterrestrial life that we have found, and you can also find life on planets aren't just creatures; they could be plant life and stuff like that. So, very, very exciting to see. So, if I look at Ganymede, we've had a look at Jupiter. I'm conscious of time because I can talk forever, and I do want to show some more. Is there anywhere else you want to go? Because we could go to another system, or is there anywhere else you want to go first before?
Where?
Do we want to go to Saturn?
You can go Saturn if you want to go Saturn.
You can go to Saturn.
Okay, I'll go to Saturn.
We're going to Saturn.
I'd quite like to have just like a sneaky peek at Enceladus, the moon, one of Saturn's moons.
Our driver, Max, did you get your destination? If you do, you're on a 5-star tip at the minute, by the way, Max, so you're doing a good job. So no loop of shame. You haven't flown too close to any celestial bodies just yet, so that's great. And you'll notice there, what you were looking at just then, for those of the eagle-eyed, you would have seen like a blue thing appear on the HUD, the heads-up display. And that's because Max was actually in the sweet spot of the gravitational pull of the planet. So you can actually use the slingshot of the planetary bodies in the game to gain speed and more momentum, which I know is what some of the Apollo missions did, right? And I'm saying this because I've watched the film, not because I'm actually smart. But am I right? They do this?
Yes, and actually it's quite a common maneuver now for lots of spacecraft, and it's how you can change your trajectory and your speed to get to other planets without having to use loads of fuel. Because if you fly direct at somewhere, you would have to use loads and loads of fuel. But if you can use the gravity assist to kind of alter your trajectory and either speed up or slow down your velocity to be able to orbit around a planet without crashing.
You should mention Bepi Colombo.
Oh yes, yeah. We didn't talk about Mercury. Poor Mercury. But
we do love you.
But we do have an epic spacecraft on display down on the ground floor in the back of the museum. And it's Bepi Colombo, which is a European Space Agency and a Japanese Space Agency collaboration to send two separate orbiters to Mercury to study it. So one's going to be looking at the surface of Mercury and looking at the composition of it, and the other one's going to be looking at the magnetic field. So it's due to arrive in 2026. It launched in 2018. So you think Mercury, it's only like 2 planets away from us, but because it's so close to the sun, it's incredibly difficult to get to because of the gravitational pull of the sun. It kind of sucks you in. So there's quite a roundabout route that the spacecraft has to go before it gets there.
It's a long way. Well, I think we've arrived. I'm going to let you pronounce this again.
And Enceladus.
There we go. Exactly how I would have said it. So there we go. Why in particular did you want to come here?
So Enceladus is quite interesting. We know from the Cassini mission, which was a mission to study Saturn and its moons. It's finished now. It discovered that there are icy particles that are ejected from Enceladus into what are called plumes. And Cassini actually, even though it was completely unequipped to do this, because we didn't know when we built the spacecraft that it was going to have, that Enceladus was going to have these kind of icy plumes kind of ejecting material from its interior out into the atmosphere. But Cassini actually was able to fly through one of these plumes. And incredibly, I just think that it's just amazing that through whatever instrumentation they've got on board, they're kind of managing to analyze some of this material and finding out really what's inside the planet, because it is also like like a lot of these icy moons, has a very thick icy crust. We think ocean beneath, and so able to kind of study and find out a little bit more about it. Also, I will just say one other thing, is that the icy particles that are ejected from Enceladus also form one of the rings of Saturn, which is super interesting.
Well, there we go. Is there anywhere else you'd like to go?
I would love to look at a black hole if that is possible.
All right.
Or
so
maybe just look at it rather than go.
So what we can do, so we're a little way away from a black hole. What we're going to do now is we're going to show you the galaxy map. And I think if we look at Sag A, now this is at the center of the universe. So just before we move any further, what you're looking at now for the audience is the simulation of the Milky Way. So every single dot you see on screen is its own star with its own system. And as we pan back, you'll see this hundreds upon hundreds of thousands of these, and we're still panning back, we're still panning back, we're still panning back, we're still panning back, and this goes on, and that's just one sector, and there we have the Milky Way in all of its glory. And every single one of those stars that you saw there, you can visit. And our players will tell you in the audience, for 10 years they've been exploring the Milky Way and have thus far only explored 0.06% of the Milky Way. And that's with a spaceship that can fly to Mars and back in a time it takes you to boil a kettle. So we've got a long way to go before we explore the rest of our galaxy. So we're going to have a look at, if possible, there we go. Fun fact, I think it was one of our commanders, correct me if I'm wrong, was it Zulu Romeo? Got to Sag A first, am I right in saying that? Someone's not yet nodding in the audience, there we go. So we have black holes. Now remember, in our game, this is based on data from 10 years ago, what we thought black holes were, and the science has moved on more significantly, which is why I'm going to throw back over to the wonderful Laura Joy to tell us all about black holes. There's not a lot we can see here because the galaxy map will take us a long time to get there, but please tell us about black holes.
Okay, so the route into black holes for this little tidbit is the Event Horizon Telescope project. You might have heard of it. You might remember that in 2019, sort of splashed across the front pages of newspapers all around the world was this sort of fiery donut on a black background, the first ever sort of published image of a black hole. And that was taken by the Event Horizon Telescope team. They decided they wanted to sort of create an image of one and see if it was accurate to sort of Einstein's equations and things like that. But because the black hole that they wanted to photograph or take an image of was so far away, it wasn't Sagittarius A, it was in a different galaxy, but it's so big that it was kind of similar to Sagittarius A, they needed a telescope the size of Earth in order to accurately get an image of it.
Wow.
Obviously, budget and other restraints would not allow, but they're scientists, they're very clever. So they created a virtual Earth-sized telescope by using telescopes all around the world, linking them together. They had to find a time, it was sort of mid to late April, and all pointed the telescopes to a particular spot in the sky at the exact same time where the black hole was and collected the data. And they collected so much data from this sort of imaging of this point in the sky where the black hole would be, that they couldn't send it to each other via Wi-Fi or email or whatever. They had to sort of manually ship it to each other. One of the telescopes, it's radio astronomy, one of the telescopes was in Antarctica, so they sort of had to wait for winter to end before they could put it on a ship and send it to either New Zealand or South America and then sort of fly it. And from Hawaii, Greenland, all these places around the world, they shipped this data to a sort of central processing site where teams of geniuses stitched it together in separate rooms. They weren't allowed to sort of overlap because they didn't want any bias in the system. They stitched it together, they added a bit of color, and they came up with this first ever image of the black hole. And recently, the Science Museum has collected one of the boxes that was used to ship data back and forth between Hawaii and sort of Boston, where it was. And it's a cardboard box, it's covered in tape and stamps, but it represents this huge science project, really high tech. And so it's a sort of humble object with a really massive story.